Now we'll be seeing about Python operators. Okay, so in this video we'll just go through few of the Python operators, and then in the next video we'll be seeing with actual Python execution. Okay, so let us briefly go ahead again. A quick recap. Our computer uses a couple of ways. So one way is to store information. Like we use computer in couple of ways. Like one way is to simply store information like a file cabinet without any paper. So again, as we have already seen, like computer thinks information as being following of data, three data types which I had discussed. So those are numbers, strings, and boolean. Okay. So again, computers operate on that information, meaning to do a necessary math or a comparison or search or whatever to help us to find information and organize in a way such that it will make sense to us. Okay. So Python offers many different operators for working with and comparing types of information. And here we'll be just summarizing with respect to we'll summarize them, and also we'll be working on these operators in the future in detail when it comes to the project execution, or also seeing with respect to learning other Python basics. Okay, so let us see the first type of operators. So these are arithmetic. So as the name implies, arithmetic operators does arithmetic operations. So they can be like addition, subtraction, multiplication, division, and we have modulus, exponent, and finally floor division. Okay, so here you can see the operator, what exactly is used. So the plus sign is for addition. So 1 plus 1, an example, 1 plus 1 is equal to 2. Subtraction, 10 minus 1 is 9. Multiplication, 3 5s are 15. Division, 5 by 10 is equal to 2. And we have a modulus. So here modulus does is it will return the remainder after division. Okay, so basically if you are working on integers, you want a result to be integer and also retain back the remainder. So at that scenario you can use a modulus. And exponential, so this is nothing but taking something to the power of, so 3 to the power of 2, that is 3 square, is nothing but equal to 5. And we have floor division. Okay, so here the floor division is basically will be dividing 11 by 5. So exactly how many times it will go. Okay, so here it will go in 2 times, and again here usually it will give us value something like 2.1. Okay, so here it will just return the integer part of it. Okay, so no reminder. So this will again give us the reminder, the decimal point also. So instead of, it is a the combination of modulus and floor division can be considered as division itself. Okay, so those are the arithmetic operators. So similarly we have few more operators. So comparison operators. So again these are used computers need to make decisions as part of their work. Okay, so but these decisions cannot be judgmental calls. Okay, but we are humans, we can do that. So anything humans will judge based on many criteria and all. So here the computers will not be doing kind of judgments, but they will be evaluating statements with facts. Okay, so these decisions are based on absolute facts. So again they are based on the comparisons. So we have few comparators operators. So the arrow mark pointing towards the left is known as less than, and less than or equal to. So both conditions, either it is less than or equal to. Similarly we have greater than, then we have greater than or equal to, and for equal to we have double equal to symbols. So the reason is, if we at all you use single equal symbol, then single equal sign, then it will be an assignment statement, which we have already seen when it comes to variable declaration, right? So in the previous video we had seen declaring integer everything, like a equal to, we are using that equal to for defining it. Okay, so we are declaring or defining a variable. Okay, so again we'll see about variables in the further. And we have not equal to. For not equal to we have exclamation followed by equal. Notice that for lesser than equal to, greater than equal to, or double equal to, or not equal to, we don't have any spaces between these. Okay, so it should be continuation. And also we have special data comparison data types. So something like is and is not. So it's like whether it is present in something or whether it is a same as uh, a value. Okay, so again we'll see this with respect to an example which will make more sense. So basically it will identify an object irrespective of what value it is or whatever it is. So we'll be seeing this with an example, and also the other like the inverted version of is nothing but is not. Okay, so is not will tell it will negate the object identity. Okay, so again we'll see that. And again with respect to the boolean, we have few boolean operators. So again it works like the final result will be either true or false. Okay, so again this can be used for like there are few operators. So again they are determining by one of the following things. So here we have an or operator, and operator, and not operator. Okay, so x or y. So if at all we have two conditions, whether x is working or y is working. So if any one of them is true, then we'll get back true. So either x or y is true. Okay, else will, if both are false, will get false. Okay, if, you can use this with respect to conditional based on decisions only. We are did the comparison operators, right? Again these boolean operators will also come in handy with respect to making judgments when final output is true or false. And operator, when both are like when both are x and y are true, then only it will be working. So basically example of what it determines, so whether both are true or not. So else other condition is false. So not of x, so if it is true it will become false, if it is false it is becomes true. So x is not full, something like that. Okay, so maybe x value is 0, and if x value is 1, so something like that. Okay, again it works on booleans itself. We'll see that with respect to examples in the next video.